So today we're talking about storing research data. And in this webinar, we'll be going through some general principles and best practices that apply to anyone working with research data. We'll think about how to keep data accessible and available also for the long term, and talk about what is the data confidentiality and how to ensure that your data stays confidential and you can then have the access for the people who actually need the data, but no one else. And we'll have a lot of case examples and examples from Aalto University and how you can work with Aalto IT services to apply these best practices in your research work. Some tools are very general, used globally, so I also think that these examples might be helpful for those who are not from Aalto University. So let's begin with some main principles. A good storage device or service, it's just a start, but the good practices are actually the key to avoid problems. So to good storage, good management of research data is more about what you do and what people do, not so much about the bits and services and computers, how the data is stored there. So it's a lot more easier to find a good storage device than actually make sure that everything has working properly and is managed properly.
Okay, so now we have some examples on what are the best practices for handling our data. And the first is on organizing the data. So now I have a problem. I had a figure in one of my articles some time ago. Now someone made a query about the figure and I need to review the raw data used to create it. The project where we did the measurements ended 2 years ago, and I don't remember exactly where the data is. There is a lot of data in the project directory that was never cleaned up. So where was that file again? And I can't find it. And what would be a good practice to avoid this the next time?
Well, as a good practice, you should have your ended project work in a meaningful place so that you know which storage service to start looking from and what was your project in question. And better yet, if you had a cleanup after your project had ended, so you would have a lot of intermediate files to look search. And actually, a few practical tips will get you very far away. So as simple as the file name is actually very, very crucial and easy to locate something you have done earlier. For example, not to use some very generic like data01, but actually have names like my project raw data, so that you can actually locate the file easier among the several files you might have in your folder and all of your project data. And then having a subfolder structure, keeping files in folders will also support your work so that you can immediately go under your project folder and under the certain subfolder. Okay, I was looking for raw data, some process data, previous version of the manuscript, whatever, a code. So you can separate everything there with the subfolder and easily find what you are looking for later as well. And with these two tips, yourself, you are quite good to go. And even more, when you work in a group, in a research group, if you agree about this naming and structure together, then all of your teammates can easily locate the file, and you can also locate the file created by someone else. And that will be a very efficient tool for your collaboration and organization, keeping you organized and keeping your data easily findable. And you can also document all of this to your data management plan and have a data management plan for your group that you can follow and also use to guide your daily work every day. And when new people come to your group, you can introduce them to your working routines using the data management plan for your group.
So here are some examples on good practices for organizing data. But these are only examples, and as said, you should try to make your own plan with your team and agree on everything together. And it may also be a project-based plan, so it might not be the same for every time for your team, but it might be based on which project you are working on. But take time to plan the structure before you start, because just starting to store is an excellent way to mess things up, because after a while everything will be very hard to find. Our example is from the Aalto Teamwork Storage Service, which is an internal service for Aalto, but the same requirements apply to basically any storage system. So name the folders and files descriptively and think about how they sort so that they stay findable. So the file name could include things like name of the task, date, preferably in year, month, date order, so that it sorts also alphabetically in good order. Version number could be there, or then something else relevant to find the data and make it more findable in general. And remember that also the order of attributes in the name affects how they are sorted. So choose the right order for your team. And separate administrative data from research data, because this is important because they are usually of different confidentiality and they should not be available to the same people. And also the size of these types of data may be completely different. So the same storage system might not be suitable for all data. So then we have another example, this time on access. One of the researchers in our group recently left the university. Now I have been assigned to take care of his part in the research project. I think I know where the data recorded is stored because it's written in the project data management plan. But when I try to access the folder, there is an access denied. So what went wrong here?
Well, you haven't been careful enough when planning to access this and actually going through where to put your research data. So you should try to have the research data that is supposed to work and stay with the organization that is not individual totally, but should be shared with others in some shared group directory that has a wide access for everyone who is actually working with the data. So in the future, make sure that you store all your research data in a shared group directory so that the other people than you alone can access it. So that would promote long-term continuity and availability of the data and sharing also during the research work. At Aalto University, we have a network drive called home, but that's something that you cannot share. So that's for the files that you are to keep only for yourself. It's okay for students as they work normally alone for thesis work of an individual or another individual work that doesn't have to be shared with anyone else. But for working teams, research groups, it's usually better to have a shared group directory, at least a shared read-only access to everyone. And even then, if you have individually named folders where you do the work individually, there would be an easy way for others to access the data. If one day you finish the work at the university and move along on your career to somewhere else. And the data should also have an owner who can make the decisions on access for the group directory and end of life. So when the data should be archived or is no longer needed, and it could be deleted to save space for other research data. And in a case the colleague has left at Aalto University and you get this error, you have to contact the supervisor. The supervisor has to find this process to recover research data. That involves at least the supervisor, perhaps a cybersecurity team, legal team, a lot of people. There is a separate set process at Aalto University how to handle these situations, but easiest is to avoid them.
So then something on cleanup. This time I'm looking for the final version of a data file that was used in an article published 4 years ago. I need the final version to repeat the simulation. When the project was finished and the results were published, we were in a hurry to get on with our next project. So we never cleaned the project directory, and there are hundreds of files in it, and we have actually not cleaned it since. All the data was just transferred to the archive folder as such, with all intermediate data and unused data left there. So now I open folder to check, and it will take days to make sure which files was the one that we used in the article, if I will even be sure after that. So how should we have proceeded to avoid this problem?
You could prepare in advance that there will be this cleanup stage. So that would be included in your project plan, and you might even have some time for it. And the sooner you start, the better. So cleaning up the data after the project is one option, but also you might be able to remove some intermediate data already on course of the project. And having a separate folders for ongoing project and archive project is a good start there. You know that, okay, we'll clean up and then move to archive, and you can have your project list separated nicely. And then you also have to remove the intermediate data, make sure that, okay, if there's some personal data and you don't have any more purpose for handling it, for example, direct identifiers after some years have passed on the latest publications, and as has been specified in your privacy notice for your research. And also you can publish the data in a data repository. The final versions, the most interesting versions you want to keep and share. If you publish them in a repository, then you have a nice published data set that you can also yourself refer to later, and it's available for others to reuse as well. And data repositories give you a lot of options how to publish your data. Will it be fully open or will it be available on request? So if you need, you can even retain some control on who will reuse your data and how.
Then we have one last example, and this time I'm backing up data. There are a couple of cases that could be real life cases, and we have seen cases like this. So I was working on my thesis in a cafe during the weekend, and I forgot the laptop there. The thesis was stored on the laptop, and now it's gone. No other problem. So I had a laptop that was broken, and I brought it in for service. The laptop had to be reinstalled, and now all the data stored on it is lost. So what should we do not to have these problems?
Yeah, unfortunately, these are quite common problems. And the one thing that you could do and should do would be to try to find a storage that has automatic backups. So not just relying only on the laptop itself or just one USB stick, but having the data, several copies in different systems, and preferably a system that will make a automatic backup to separate media. And for us at Aalto University, we have Aalto network drives that are replicated and backed up to separate media. So that's you can trust that scheme. It has a good backup scheme, and it's automatically backed. If the backup is something that you will always have to trigger yourself manually, or remember to copy your data from laptop or USB drive by yourself, there might be it might not be that regular and easy to forget, and you might lose some work for quite many days. And cloud storage services such as Microsoft OneDrive, Teams, Google Workspace are also good for the data durability. They don't usually have this kind of separate media style of backup that you do in one data center, but instead a cloud has a replication scheme that the same data will be in different data centers and different storage systems inside the cloud actually. So, and that results in very reliable service. So it's definitely better to have the data once in a cloud storage to have it rather than have it in only at one laptop or one USB stick. So avoiding using these USB drives or the local hard drive of a laptop alone for permanent storage. If you need permanent storage and this data that you cannot lose, that would be the main thing to consider. And having something else as a backup, and preferably something that will do the backup automatically, would be the best advice and the most straightforward way to go in backing up your data. But this is like a really important best practice that you should follow.
So our next section is now on how to collaborate cross-organisationally. and mostly cloud is the tool that's used for that. So we have a case again. And in this case, we need to collaborate and share data with people in other universities and businesses. Aalto coordinates a project with participants from other universities and companies in Finland and Europe. One of the conditions is that the data has to be stored in the European Economic Area. So which tools could we use and which methods would be good for this?
At Aalto University, we had an agreement, for example, with Microsoft, and that for our Microsoft 365 services are provided from the European Economic Area, and then you could use Microsoft Teams to build a Teams area for all of your organization and invite all of your collaborators to join that team. You can communicate using chat, you can have meetings with team, and of course you can store the project data in the files on the Teams area. Even if you need to have some separate subgroups or administrative data for restricted to some people only, you can then have some private channels and spaces so that only some part of the team can access and see those. But then each participant, each partner cooperating there can, for example, use a little bit of user management and share who are the team members there. And for example, the admin persons could have a private channel for sharing the administrative data if it's something that all researchers should not have access to. And you can, with this, share the files only with identified users, keep them to teams, and it's only accessible to the people that belong to your team. And there's also a wide range of platform support for Microsoft Teams, so you can use it on Windows, Mac, even Linux systems and phones, mobile phones. So it's very likely that everyone in your collaboration parties can have the teams and using with their common tools. So that would be the main alternative, or the first option we would propose here at Aalto University for this case. And for an example, how to then practically use the teams and how to do the sharing. So once you have created your team, you can manage team and add members to team by using the manage team function. And by add member, you can enter emails of the person, so you just have to know emails who are you going to invite, and then you can have their role. So your team should have 2 owners to ensure continuity, that there will be always someone who can add members, remove members, and manage the team, and then as many members and guests as you need. People from other universities who don't have an Aalto account would be given a role guest at Aalto University. And another thing under settings you can make sure on the team details is the privacy setting. So go to Manage Team and choose the Settings tab, click Edit, and then change the privacy to private so that only team owners can add members. So that will keep the team private to only the people that participate to your project and your collaboration. There are 2 options, private and public. And public means that anyone in Aalto University having the Aalto account, students, staff, some of our visitors can find the team and join it freely, and also see all the data that has been shared in the team. So for research project, the public option is hardly ever good. So you should always choose the private and list the names of the people that are actually part of your collaboration. And when you are using cloud services, you also have to think what happens when it's time to archive the project, or the project will end, or if the project and collaboration will last for many years, the people will change during that course of time. So using a cloud service to ensure how to get a group access to data. So prefer the services that have team folders like the Microsoft Teams, that there's always team and several people with the full rights. For example, if you use OneDrive, then there's always a single account and single person who all the data will be attached to, and it will also tie to OneDrive or with Google Drive to one person account only. And then it's the individual account that will get closed when the owner leaves, and then you cannot no more have the ownership and manage and control the files of the project, so you cannot change the ownership anymore. So before the owner leaves, they should always transfer any Aalto data in OneDrive or Google Drive to another owner that still stays at the organization. So that's why for the teamwork and project work, starting with something like SharePoint, Microsoft Teams, or with Google Shared Drives would then be the recommended option to ensure that access will be given to the whole group. And then you can also think what happens after the project. Are you going to close the cloud service, Teams area, and with the access? And where will you put the data and what data to archive? Will each participant choose what they archive themselves, or we coordinate to archive it for everyone? And how can you actually give access to different people or keep the access rights updated if the project will end? So one good option here is just to close the cloud account, cloud service, and publish, for example, the data, what is publishable at the data repository. And then there would be a long-term access to public. And if you are restricted access, you can even control it a little bit more by answering to access requests. But using the archiving scheme of your organization, how to get the data and have it somewhere else. And that would keep the long-term availability, because it will be hard to keep the access rights updated to a Teams side of the project that had already been ended. And also, of course, cloud, as I said earlier, it's a reliable storage technology with replications and separate backups, probably not needed for the data durability point of view. But of course, there are some other risks how to keep the data available. For example, if you delete something by accident, it's available in a recycle bin for a while, but then it's gone. So you have to find out that, okay, something has been deleted, I need to return and restore it. And with cloud, you will need a network access. So if there's a network outage for some reason, you might have short-term access problem to your files. If you have a laptop, you can synchronize those cloud services, so you actually have a copy on your laptop hard drive as an offline copy, and then you would have an offline access for these short breaks. And that might help you there. And of course, some risk that there might be some changes to service agreements might say the cost might rise, so that the university or project might not have the funding needed to continue with the service that has been used before. Companies might merge and choose another focus or change licensing. And of course, there might be some political issues involving what data can be kept in which service. So if you have really crucial data that you want to keep no matter what happens, then you might also consider having a backup somewhere else than in the cloud service.
So then we have a small section on confidential data. Can move on to the next slide. So confidential data is only for specified people who need the data in their work. Confidential is usually required by legislation, like with personal data, or agreements, the data owner or his or her organization. An example from Aalto of data that is confidential is, of course, personal data of research subjects, trade secrets of research partners, and research results prior to publishing. Some key points in taking care of keeping data confidential. Make sure that everyone knows the restrictions, how the data can be used or shared. Set up access restrictions and keep them up to date. Take care to ensure the correct identity of your collaborators. Usually this means double checking that their email address is correct, because a mistake with an email address is usually a data breach, since someone who should not have had access to the data. Or at least it's possible, because we have no way of knowing who has accessed it. And require login instead of sharing an open link that works for everyone, because a link can easily be sent on by mistake and there is no trace who has used it after that. And use separate strong encryption for added security. That's especially needed if you have data that is classified secret, but we will have more on that in another webinar in a couple of weeks. So, sharing confidential data in OneDrive. Here we are starting with Windows File Explorer, where we right-click on a file or a directory in the File Explorer to bring up the context menu. Then select Share to bring up the window for sharing options. For confidential data, sharing setting needs to be people you choose. For public or internal data, also the option people in Aalto University is okay. And the default setting in Aalto is now people you choose, but it may be different in another organization, so take care of this. There are also options for share for viewing only in more settings. Anyway, it's done so that you insert the email of those who you want to share the data with in the first window. Double check the addresses, be sure of confidentiality. And then an automatic email can be sent to the receivers, so you can edit an optional message. If you want to remove access, select Share again in the Windows File Explorer. Then you can edit access by clicking the user icons down left in the sharing window. Click a user to change their access, and you can also remove all the sharing links in that window. And adding a new user later is also done in the sharing window. But please check that the setting people you choose is the one that is active and it's the one you need, because it might change and you will want to take care that you do not resend without having the right option set. So then we still have an example on sharing in Google Drive. So again, we start from Windows File Explorer. So again, right-click to bring up the context menu and select Share with Google Drive to bring up the window for sharing options. For confidential data, use the setting restricted. For public or internal data, also the option Aalto University is okay. So these are basically the same options as in OneDrive, but the terms are a bit different in Google Drive. And again, in Aalto, the default setting is restricted, but it can be different in other organizations. So insert the emails addresses of those you want to share data with, and again double check the address. And when adding users, there is an option for giving the new users editor access or only commenter or viewer rights. And also here there is an automatic email that is being sent to the receiver, so you can edit the text. And to add more users later, select Share again. And there you can also remove access by clicking the status of a user all the way to the right in the picture. It's where you can see owner. So that's how it's done with Google Drive. And then I think we are moving on to storage services.
Yeah, and then some percentage of storage services available at Aalto University for your research data. So our internal storage services, network drives, and they come in different flavors called home work, teamwork, and sec work, and all of them are based on the same technology and are very similar to use. And out of our different services, teamwork is the service that we recommend for research data. And we can also arrange an access to teamwork to specific folders for different closed networks that have research workstations or measurement data devices, and so that we can use it in a very customized way and to solve a common storage needs around the university. And these internal storage services have the access controlled by Aalto IT services or your department admins, and we can grant access to anyone with Aalto account. So, or to use it, you have to have an Aalto account. There's no external collaboration. Any email won't work, but you can then possibly have some academic visitors and with academic visitors can get a visitor account and access these services with a visitor account. You can have remote access if you have the VPN software installed and you have an Aalto account. So you can work from your home or also outside the campus, access this data and the services. And we have an automatic backup system based on both snapshots that are created hourly and are easy to restore yourself. And you can restore previous versions of files using this snapshot very quickly. And then we are also running a weekly backup on a separate medium to another service for a long-term backup and for this disaster risk recovery. So if something is, you notice that something is missing and some months have already passed, then we can go to use the long-term backup to find your data and restore the file needed. And there's a link that you can follow later from the slides if you want to learn more about file backups at Aalto University. And here is a window from an Aalto workstation, and we can see several different drives mapped here. So typically, each one of us has a home directory that's meant for some perhaps personal files, individual files, and some configurations files and such needed by systems, operating systems and such. So you have a called data, and usually in Windows with the letter Z. And you can see the drive mapped here. And here's also example with a teamwork drive for the example research group. So it has been mapped to its own letter as its own network location for the research data work. And if you have your OneDrive account, will be also visible and copied and synchronized to your computer here. So from here you can access the OneDrive cloud files and locally from your computer and get it uploaded. And in the previous examples for sharing, they were using this Explorer, going to the OneDrive copy and then right-clicking, you can access also the sharing. So you can even share, upload the files and work with OneDrive files from your Windows computer Explorer. And other options that we have, Dropbox is supported and Google Drive as well. And you can map the Google as a network drive to Windows computer, and Dropbox is visible at its own category right here. And the data that you wish to keep for permanently should be located somewhere which has automatic backups. So that would mean the home, teamwork, or one of these cloud services. Don't use a separate folder inside your hard drive because there's no backups for that automatically, and you might lose your data if ever the laptop something happens to your laptop, or even if it has to be reinstalled. And when you are thinking about what kind of storage you need, we often question, or you will have to talk with me or another IT expert about research storage. You often get a question, how much capacity do you need? And what data is big when we talk about all the storage systems from an IT perspective? So we have different categories here. Each time we'll tenfold the capacity, and the basic capacity setting, it's called small, but this is actually for many of us, this will be plenty. But for example, the default quota we have for the home directory is 100 gigabytes. And you can store administrative data, office files, Excel, or tabulated format, structured data and format. A lot of this data could fit in your research project to this 100 gigabytes. So it will be plenty. And you can use the cloud services, internal network drives, a lot of options. Any storage services can handle this amount of data very easily. And sometimes you have a plenty of things to do, and software, special software or special research setting that will generate more and more data in size. And when it comes from 100 gigabytes to the terabyte, then you talk about medium, and you could have some video interviews that have high quality video for an hours of a workshop or this kind of recordings. Those will pile up some value. Or if you use a basic settings on your mobile phone and take a photo, then you have a 10,000 JPEG photos that will take over 100 gigabytes. So if you have a really special research setting that will generate 10,000 images and photos, then you might get to this category. But quite a lot you can do as a research and still be on the small side. And when it comes to this large, at Aalto we would prefer using the internal network client teamwork when we can organize with a cost-efficient way and good performance for your data, research data. And going more, if you have an imaging data from the measurement devices, you have taken photo files using a digital camera in a RAW format or some other measurement data, you might end up having something more than 1 terabyte, 2 terabytes. And we can still fix storage space at Aalto University from Teamwork service there. So no problem there. If you produce more than 10 terabytes, then from the IT perspective also, you are like a heavy user, and we would like to discuss with you more closely what's your case and how you are going to store and what's the best option as a storage option for you. And if you have, say, more than 20 terabytes, we might even have to check that we can actually arrange the space for you from Teamwork. Most likely we can, but of course an advance notice would be highly appreciated in that case. But for example, simulation data, computer simulations can produce a huge amounts of data, a lot of imaging data from big instruments, or if you collect this kind of work in a long time series, so you have something photo files that are getting over time, like for 10 years, 8 years, you might end up your project could accumulate to this category. And 100 terabytes is like kind of a technical limit we have for the Teamwork service. If you go over that would be extremely large, and then we have to think about another customized arrangement for your data, and also to think how to keep this kind of a large data managed. But mostly if you are doing basic research with some office files, not too much measurement data, you will most likely be working with the small or medium sized data set. But this depends heavily on the discipline. So at some disciplines it's normal to have use work experiment data with some measurements, or use computer simulations that will always create millions of files or a lot of data. And then you just have to work with large data. And of course, that raises you have to be more careful how you handle the data if you have a large data, because there will be very quickly performance issues working with the data. And if you have hundreds of files, you will need some code and automatic handling of it also. But there's a good reason for you to think about data management in that case. But don't worry, most likely we can find a service suitable for you. And also, not only the size, there are also other issues that we can look when trying to choose a suitable storage service for you. So the largest we have are the Teamwork is the option that we can use for the heavy usage needs. And also, if you want to publish large data sets, then there's the Fair Data IDA service that can give a fair quota for you if you need to publish a large data set. And during the project, you can use the Teamwork. And for the purpose, and there are different, something that is good for sharing, something is good for confidential data, and homework and teamwork are good for keeping the data confidential. It's only for the Aalto group, and they will also give you the best performance in terms of the access speed. So the data is closer than it would be in the cloud, so that will make the software and everything working more smoothly. And then, of course, when you go to the scientific computing side, we are running cluster, you have to have the data actually even more closer. So then the teamwork would be only for the data at rest, and during the calculation and simulation, the data would be in the cluster itself, very close to the calculation nodes. And then we have a distinction about who can use these services. So some of the services are available for the Aalto staff only, researchers, and if you are a student, then you have a little bit limited options to choose. But the students can use the home directory and enjoy the 100 gigabytes available there. They can build team sites, use OneDrive, and also Google Drive. So those are good options for students for collaboration. And if students participate a research project and become in that way also part of the Aalto staff and can have access to, for example, project teamwork. And for collaboration, we recommend the cloud services, Microsoft Teams, eDuni, OneDrive, Google Drive, Dropbox. Usually the choose between OneDrive, Google Drive, and Dropbox is about what your collaborators use. So between the teams who collaborate each other in an organization, you might try to find a common tool that everyone is happy to use. Sometimes easier, sometimes more difficult. And if you have only internal data of Aalto research project, so you don't have external collaboration, then you can set up your collaboration in teamwork. And with outside of Aalto, I would recommend, for example, looking at Microsoft Teams for research projects for the inserting the group access, or OneDrive, for example, just sharing a single files in individual manner. So to sum up this webinar, your data is the most valuable asset that you have got. So take good care of it. And don't worry if you have any problem, we are here to help you. We'll be happy to find the best tool for you, best service for your data and case, and help you also with the practices how to work with the data.